I'm Anil Kumar. This video is for my student Amandeep. Thanks for sharing the question, and I hope many of my subscribers will gain from the knowledge of sketching such graphs. The question here is, sketch graph of f of x equals to x to the power of 4 minus 9x cubed plus 27x squared minus 27x. I have purposely given this topic polynomials in factored form, since sketching a graph becomes much simpler when you write it in factored form. So the first step here is to factor the given polynomial. We are given f of x as equal to x to the power of 4 minus 9x cubed plus 27x squared minus 27x. You can always factor x, correct? So first step is let's factor x. Then what do we get? We get x cubed minus 9x squared plus 27x minus 27. Now this part can be further factored. I hope you remember the formula for a minus b whole cube, right? So that will help you to factor this one. So it could be factored as x minus 3 whole cube. Now, just to remind you, the formula for a minus b whole cube is, let me use the formula here, a minus b whole cube formula is a cube minus 3 a square b plus 3ab square minus b cube, right? So in our case, a is x and b is 3. So when you put that, you get the factored form, right? So it is x minus 3 whole cube. Now I can understand that could be a difficulty. Remember these formulas of a minus b whole cube and also a plus b whole cube. If it is a plus b whole cube, then the change in the formula is that all these signs are positive, right? So all these signs are positive. So that is kind of change. Now once you have the polynomial in factored form, it is kind of simpler. So you can actually now pause the video, sketch, and then check with my results. So now when we need to sketch a graph in factored form, few things are important to take into consideration. One is, let's find the degree of the polynomial. Now in this case, degree is 3 plus 1, 4. So basically the degree is even, right? And then let's find the leading coefficient. Leading coefficient for us is x cubed times x. So the leading term is x to the power of 4. It is positive 1, right? More important is positive. These two things decide the end behavior. So let us show it on the graph itself. Let's say that's the coordinate plane, x and y axis. When we say that degree is 4 and leading coefficient is positive, positive leading coefficient means right side up. Right side up. That means the graph will end here, right side up, right? When we say even, then we say both same side. Now both same side means the right side is up, the left is also up. That is, both are on the same side. So that is the end behavior. When x approaches negative infinity, y approaches positive infinity. When x approaches positive infinity, y approaches positive infinity. So in both cases, right? Now we need to find the x-intercepts. So x-intercepts for us are at x equals to 0, the first factor. The next factor is at x equals to 3. So these are the two x-intercepts. Now these are the zeros also, since y value is 0 at these points. So when we talk about zeros and x-intercepts, you know the difference. Zeros have order or multiplicity, right? Now in this case, the order is 1. That means it's a linear 0. And here the order is 3. It is cubic 0. So it's linear 0. And this one is cubic 0. That really means that at the x-intercept x equals to 3, graph will turn like a cube. X-axis is going to be horizontal asymptote, and the graph is going to cross the x-axis. I'll explain you when we sketch this, right? Let me first mark these zeros. One of the zeros is at 0 itself. The other one is at plus 3. Let us say this is 3 for us, okay? So this is 0 for us and this is 3. When we say that linear 0, it means it will cross like a line. We are coming from quadrant 2, so the graph is moving from quadrant 2 to quadrant 1, correct? So if you're coming from quadrant 2, it is going to cross like a line. That's what it means, linear 0. Cubic means x-axis will be tangent, kind of like this. Do you see that? And then it moves, crosses. So that is how the graph is going to be. Now actually, we can just connect them and finalize the graph. So it's just connecting with a smooth curve like this. Do you see that? And that's it. So that becomes the graph of the polynomial, right? So we can always write f of x here, and the y-intercept is 0 for us. So we can check f of 0. If I substitute 0 times anything is going to be 0. So that becomes the y-intercept, and this is the graph for us. You can always take few more points, put them on the graph paper and draw more accurate graphs. Anyway, this graph gives you 90% of the things. One or two more points here and there will actually help to accurately sketch the graph on your graph paper. So I'll recommend find the value of the function at, let us say 1, and at -1, and then you'll have kind of scale on the y-axis also to show an accurate graph. I hope, Amandeep, this really helps. A sketch like I've drawn is actually good enough for your test papers, but it's always a good practice to at least show a couple of points. As I'm saying here, just plug in 1, calculate your answer, and put those points on the graph paper for more accuracy. I hope that helps. Thank you and all the best.